Hello and welcome to another United Learning Required practical video, this time for the GCSE Physics course. Today we will be looking at thermal insulation, a concept we use in our homes, in our winter clothes, and in maintaining the temperature of hot food and drink. Today's practical is divided into two parts, and for each of these experiments we'll need to get creative. For these two experiments we will need a kettle to heat our water, a measuring cylinder to measure out equal volumes, metal cans surrounded by different insulating materials, a thermometer to record final temperatures, and a timer in order to give an equal time. When a metal can is filled with hot water, it's got plenty of thermal energy. Now that thermal energy will be transferred to the surroundings, and it's done in two main ways. The first is conduction, and the conduction happens both from the can to the tabletop, but also from the metal can to the air, as particles in the air collide with the vibrating particles in the metal tin. The second way energy can be lost is through convection, but there's a very simple way to prevent that from happening, and that's simply to place a lid over the top of the metal can. So our first practical is to change our insulating material. You can see here my kettle has just boiled and I'm going to pour out 100 millilitres of water. When I'm comparing different insulated cans, it's important that I insulate both the side and the base. Unfortunately, insulating the base can make these cans quite unstable, which is a real hazard when they're filled with hot water. That's why I'm using a tray here. If instead you are using glass beakers, then you would want to fill the smaller beaker, you would want to make sure this was insulated, and then you would place it inside a clear, larger beaker in order to secure and stabilise. I will also be comparing my results against an uninsulated can so I can see the effect. All I need to do now is pour my hot water into one of these cans, place the lid on the top, and wait for the temperature to stabilise. As the temperature of my thermometer rises to the temperature of the water inside the can, it's important to remember that I could have used more than 100 centimetres cubed of water. However, if I'd done that, it would have presented a hazard in me handling the equipment. So we can now see that my initial temperature is at 68 degrees. I'm now going to start my timer and make a note of that in the first row of my table. Monitoring the time carefully, I'm going to be recording the temperature every 3 minutes for a total of 15 minutes. You can see my values look something like this. Small differences in the initial temperature aren't hugely important, as we should see a significant decrease over the 15 minutes. And repeating this process for the newspaper and the carpet, we get the following results. Finally, I can calculate the change in temperature from the beginning to the end and use this to evaluate which of these was the best insulator. Remember, the best insulator is the material which slows the energy transfer most, keeping the temperature highest for longest. Our second practical is very similar to the first. We change the independent variable. Now, the independent variable, that is the thing that I will change during this experiment. And before it was the type of material, this time it's going to be the thickness of that material. So here I will choose just one type of insulating material, and I'll choose newspaper for convenience. And I'm just going to increase the number of layers of newspaper surrounding the metal can, going up 2 layers at a time. So starting at 0, and then 2, and 4, and 6. And the dependent variable, the variable that I measure, that will of course again be the temperature of the water, keeping everything controlled just like before, the volume of water in particular. Again, I'll just add 100 millilitres of hot water to my can, I'll add my lid, and I'll use a thermometer to measure my initial temperature, and as soon as I'm happy that that's stabilised, I'll start my timer and record values for every 3 minutes, again for a total of 15 minutes. You can see that my values for 0 sheets of newspaper are as follows. Here I can calculate the total decrease in temperature to be 28 degrees Celsius. Repeating this procedure with 2 layers of newspaper, and then 4, and then 6, I get the following results. Now, there's a lot of information in this table, and we need to find a way to represent all of that in one chart. Let's focus on just 0 for now, the time that I used 0 layers of newspaper. I can plot these results with time along the x-axis, as that's what I allowed to change, and the temperature along the y, as that was my dependent variable, the variable that I measured. Plotting these against one another, I get the following results for 0 layers of newspaper. I can then repeat this process for 2 layers, 4 layers and 6, and I see the following, and here I've shown every relationship to be a different colour. And as one might expect, the more insulation there is, the slower the temperature falls. And there we have it, 2 physics practicals for the price of 1 here, showing us that we can compare different insulating materials to find which works best, and also that the more layers of insulation we have, the less the temperature decreases, as one might expect.